So guys, 8.3 is titled Similar Polygons, and like I said, when we were leaving into break, we were dealing about this, and I think that we said similar polygons were going to be the same shape, but what was changing? The size was. So we were talking about things that were the same shape, but they're going to be a different size now. So guys, in 8.3 titled Similar Polygons, essential question is pretty straightforward today. It says, how are similar polygons related? All right, so let's just talk about goals here quickly. Anybody want to read a couple of these for me right here? What's the first one say, kids? Use similarity statements. Second one says find corresponding lengths to similar polygons. We're going to look at perimeters and what? Areas of similar polygons. There's going to be some rules that come with that in terms of units. And then we're going to decide which polygons are going to be similar today. Okay, kids, I need you to see if you remember how to do something like this. I'm going to just over here as a note write this down. Do you remember how to do? I'm going to write this word right here. What's that say there, kids? Proportions. You remember how to solve proportions? You ever heard the old cross multiply and divide? So let me give you an example. If I had something like this, if I had 3 is to 7 as maybe x is to 28 right there. Guys, help me remember. It's been so long ago. Might have been even last year where I was doing stuff like this. How do you solve something like this? What would be the rule? Well, guys, we look at cross products being equal. Okay. All right. Isn't this the cross product where you have two numbers? And isn't this the cross product where you have a number and a variable? So when I say cross multiply and divide, cross multiply the two numbers, or in other words, the cross multiple has both numbers. So isn't this the cross multiple with numbers right here, kids? I would do 28 times what? And then divide by 7. Okay, so to solve that, you would go 28 times 3 divided by 7. Now, kids, other people think of it this way. Kids, what would you have to multiply 7 by to get to 28? Okay, so if I multiplied the bottom by 4 to get to 28, what would you have to multiply the top by to get over to x? Okay, well, what is 3 times 4? You would get 12 here, wouldn't you? Okay. Another way to do this, kids, I just say, well, do 28 times 3 and divide by 7. All right. Kids, I kind of like to mix stuff up sometimes, but what is 28 divided by 7? 4 times the 3 in the middle, and I'm going to put you back to what? 12. You got the same thing, okay? So keep that in mind, all right? Remember how to do proportions. I'm just going to throw one up on the board here. You guys tell me what the answer is. Let's go 4 over 9 equals 36 over x. Now, if you need a calculator, feel free to get that out. Cross multiply and divide, or some of you might be able to do it in your head. Anybody want to take a stab at x right there? If you're not sure, what would you multiply together first, kids? What two values? 36 times 9, then divide by what? 4, okay? I'll just tell you another way to do it is, what would you have to multiply 4 by to get to 36 up here? 9, so what's 9 times 9 at the bottom? 81, right? Okay. With me on that, friends? Okay, if you weren't sure, you've got calculators, make sure you use them, okay? All right, let's establish some vocabulary here first before we start. Oh my gosh, didn't want that to happen. All right, let's try this again. All right, similar figures first. Anybody want to go ahead and read that for me? Similar figures are what, my friends? Same shape, same size. Guys, are the blue trapezoid and the green trapezoid the same shape? Or are they the same size? No. No. So, guys, same shape, same size. I'm sorry, same shape, different size. That's what I meant to say. Okay, so that's probably what probably want to highlight here. Same shape, but not necessarily the... Okay. All right, so that'd be important to know there, okay? Guys, a similarity transformation. A similarity transformation is typically going to involve a what? When we started doing dilations, we were changing size a lot. We weren't necessarily changing the shape, but we were changing the size of that shape. Okay, so right here, kids, one thing they might do here is to go from the blue triangle to the red triangle. They slid this over and up a little bit, and then once they did that, what happened to go from red to green? Did the size change at all? Go from red to green then? Yeah. Okay, so simply saying that it looks like the blue triangle was the original. They slid it over and up to get to the red triangle. That was the first image. And then to go from red to green to this A double prime or to this second image, they changed the size by dilating. Okay. So guys, when you have a similarity transformation, typically it's going to be a dilation, or it could be a composition of rigid motions and then a dilation. Just keep in mind, rigid motion again is simply just moving it somewhere first without changing size. Okay. Kids, we're going to talk about corresponding parts a lot. Okay, this is going to be an important concept for us to prove similarity. Corresponding parts, important definition. It says it's a pair of sides or angles that have the same relative position in two congruent figures. Okay, kids, take a look at this diagram right here. I'll blow this up. Ready? Boom! I blow it up. All right, kids, look at angle A down here. How many arc marks do you have for angle A? What? How many arc marks for D? Okay, so they kind of say angle A and what? They are what? The same, congruent, okay? How many arc marks at B do you see? And where do you see 3 arc marks at here? It means that angle B and angle E have to be the same measure, okay? How many arc marks at C and F? 2, okay? So that just means that C and F have to be the same, okay? Now, do you guys get the tick marks on the outside? How many tick marks from B to C? What's BC have to match over here? E to F, right? Okay. What does BA have to match? E to D, because there's 2 tick marks for them, okay? And then how about side AC? What's that have to match? Okay. Guys, when we talk about corresponding parts, there's 2 parts that we have to consider. We have to consider corresponding, here it is, corresponding what? And what else? Corresponding sides, okay? Now, big core concept and parts of similar polygons. Okay, I'm going to put a little star in here. Means it's important. I'm going to read this real quickly. You try to follow along as I'm reading this, okay? Core concept involves corresponding parts of similar polygons. We just said there's corresponding angles and corresponding sides. Within the diagram down here, it says triangle ABC is similar to what, kids? Says you can write ABC is similar to triangle DEF as ABC is, you see this little squiggle mark right here, or this little tilde sign? That little tilde sign right there just means that they are similar. Okay, it says triangle ABC is similar to triangle DEF. All right, I'm going to highlight that right there. Oop. Okay, this little sign right here simply means they're similar. Same shape, but different what? Same shape, different size. That's what that sign means, okay? A similarity transformation, okay, I'm going to underline this. It says it preserves what? So corresponding angles are always going to be the same measure. Like down here, if I told you angle C was, I don't know, 40 degrees, what would angle F have to be? If angle C was 40 degrees, what would angle F have to be? 40 degrees. Angle measures are not going to change. That's what they mean by preserving angle measure, okay? It says those corresponding angles are going to be congruent, all right? Then the next statement goes on to say a similarity transformation also enlarges or reduces a side length by a scale factor of k. So corresponding side lengths are going to be proportional. Now I'm not going to read through all this down here, but again, things you understand is corresponding angles, ratios of corresponding sides, okay? Here's the deal. I'm just going to put some numbers up here. How about if I said side A was equal to, let's just put some numbers in for A, B, and C. Like maybe, let's just go 5, 6, and 7. Okay? Suppose I tell you A is 5, B is 6, and I'm sorry, C is 6, and B is 7. All right? Now, do you guys see this distance from K to A right here? Let me just tell you, maybe this is 15. Okay, do you agree that this 5 kind of matches the 15 over here? Well, how many times bigger is 15 than 5? Okay, so if these two figures are similar, what we really did down here was we took A times what value to get to 15? Well, A was what value here, kids? We took 5 times what to get to 15? Okay, and that K value would have had to have been what? 3. Okay, kids, if this is 15 right here, what's the distance for KC? Why 18? 3 times 6, right? This is like saying, well, take this distance 6 right here times what? Get 18, right? Okay. All right. What would KB have to be? That distance for KB? 21. It's just 7 times what? Okay. In this case right here, K would equal 3. We're multiplying everything by 3. It's like saying a scale factor is 3. Think about this, kids. The angles are going to be the same. Don't worry about angles. What I'm worried about is this ratio of sides. Kids, what's the distance from D to E, the way we wrote this in here? 18. What's the distance from A to B? Okay, you agree that, well, guys, this ratio of D to E, which is 18 here, and this distance from A to B, which is 6. What's 18 over 6 equal? Okay. Coincidence? I don't think so. They talk about EF over what right here? EF is right here, which we called what value? 15 over BC, which is 5. What's 15 divided by 5 make? 3. Okay. How about this distance down here, 21? What's 21 divided by 7? 3. Basically, we took all sides in the smaller triangle, multiplied it by what? To get the distances in the larger triangle. Okay. Did we change the size? Did we change size of triangles? Or did we change the shape? No. Okay. Will angle measures change or will side measures change? Sides will change. Okay. So I'm going to just say this right here. Corresponding angles, they're going to be the what? You would say same. But the ratios of corresponding lengths, the lengths are going to change a little bit. So there's a lot there, and I think that you get it for the most part, but I can see where there could be some things that are confusing. So let's start looking at some examples that would help us understand this here real quickly. How much more time you guys need on that bottom part? Questions so far? Okay, let's look. Let's look on page 2 here. Okay, page 2. Oh boy, using similarity statements. First of all, kids, it says this. In the diagram, triangle ABC is similar to what? Okay, now I want to remind you of some things right here. What variable is listed first in the triangle? What variable is listed first, or what vertex, I should say, is listed first in the second triangle? Means A and J would have to match, right? So let's just pretend this. How about if I told you angle A was 100 degrees down here? They don't give you an angle, but if angle A was 100 degrees, what would angle J have to be then? Okay. So guys, here's the first question up here. It says find the scale factor from ABC to what? Okay, so here's the deal. Anytime they ask you to find a scale factor right here, I'm going to give you a little formula, okay? Scale factor is going to equal an image size, or how do I always say this? An image over the original. Okay? This says go from triangle what, kids? To what? Okay. Basically, they're saying if we're going from ABC, this is where we started, right? And this is where we're ending. Okay, we're going from this triangle. We're going from this triangle to this triangle right here. Okay. Now, guys, to find the scale factor is pretty simple. Okay. Pick one length in the image one. Which one is the image one? Well, that's the ending one. Pick one of these lengths, 36, 28, or 48. What do you want? Which one? You're picking 28? Okay. So I could say the scale factor could equal 28 over, what's 28 correspond to, kids? 21, doesn't it? Okay. Now guys, think about that fraction right there, 28 over 21. Can you think of some numbers that would go into 28, 21 to reduce that for us? 7 would go into both, right? Okay. How many times will 7 go into 28? How many times will 7 go into 21? What's the scale factor here? 4 to what? 4 to 3. Okay. Well, what if I pick 36 over 27? Wouldn't 9 go into 36 and 27 here, kids? How many times would 9 go into 36? How many times would 9 go into 27? Oh, that's that scale factor, 4/3. By the way, 4/3 more than 1 or less than 1? More than 1. Does it make sense that our scale factor would be more than 1 starting here and ending here? Because the triangle got bigger, okay? It was an enlargement, all right? So scale factor, kind of take your ending distance over a starting distance. Can you handle that? Okay. Now it says list all pairs of congruent angles. This is easy. What's angle A have to be congruent to, kids? Say again. What's angle B have to be congruent to? What would B match up with? All right, and then finally, what would angle C have to match up with? Then it says write the corresponding side lengths in a statement of proportionality. This is pretty simple, kids. You're just going to go through each part, okay? I'm going to pick the image first here, kids. J over K would have to match what side? Okay, so the ratio of JK to AB would have to equal, okay, so I've got one side, J to K. Let's just keep going around here, J to K, and then the next side would be K to what, kids? So we know that would equal K to L. What's KL correspond to? And then we've got this third side of that big triangle, which would be L back to J. What would LJ have to match up with? Okay. When they say write your ratios of corresponding side lengths in a statement of proportionality, you would say the ratio of J to K is to AB as that distance K to L is to what? That's like two more slanted sides right here compared to each other. Or that ratio could also compare LJ to what? All right. So I think you get that. Guys, I know I went quickly through that, but does that make sense? Now, if I would have switched this around, what if I would have had AB up top and JK on the bottom? Then what would I have to do with these other two ratios right here? Flip them, okay? So make sure whatever triangle you start with, you know, if the first triangle was the big one that you started with, guys, aren't all these distances that I listed right up top here from the big triangle? And aren't all the distances on the bottom that I listed from the small triangle? Okay, and you can switch them around as long as you stay consistent. If you start with the small one on top, leave the small distances on top. If you start with the big distances on top, leave the distances from the bigger triangle on the top. Okay? All right, so let's look at one more core concept here again. You might want to read that core concept about corresponding lengths in similar polygons. All right, perfect. Okay. So what this is really saying, guys, is this. It's kind of like saying the following. It says in this diagram for corresponding length, it says these two triangles are, what's this symbol mean right here again? So GHM is going to be similar to HKL. All right. It says find the value of what, kids? Okay. Can you guys see this bigger triangle up here compared to my smaller one right down here? Our job is to find what, kids? What's X correspond to in the smaller triangle? What distance? X is kind of like the what here? So what I could do is this. I could say the distance X is to 12 as, all right, in those two triangles, the big one and the small one, you know two side lengths that correspond to each other. If I pick 15 in the bigger triangle, what would that 15 correspond to in the smaller triangle? Okay, now keep in mind here, I want X is to what, kids? I want from a distance in the big triangle to the small triangle. That's got to be the same as the ratio in the big triangle. 15 is to what? Or I could have done 27 is to what? Okay, I'm going to use the 15 and 10. So I can say that ratio, x is to 12 as 15 is to what here, kids? You guys agree with that? Okay. So this ratio, x over 12, that matches right here, has to be the same as 15 to what? 10. Okay. Kids, what have I set up there? Starts with a P. Set me up a proportion, didn't I? Okay, what times what divided by what here, kids? 12 times 15 and divide by what? Okay, so let me do that. 15 times 12, cross multiply right there, and then divide by the part that's opposite or diagonal of the variable, x, so we'll divide by. What's that distance, kids? Okay, there it is, 18. Guys, think about this, and you'll know you're right. Guys, what's the 15 correspond to? If I go 15 divided by 10, what do I get? Okay, what's the 18 correspond to? Careful. This 18 just corresponded to the 12, didn't it? Kind of confusing the way they've got that drawn in there, but let's just check this. 18 divided by, divided by 12. What have you got there? 1 point. You don't say. What would be the third side to compare? 27 over what? Oh boy. Anybody want to guess what 27 divided by 18 might be? Fast question is, what do you think the scale factor is? You probably say it's what? 1.5. Okay. All right. To go from a small triangle to the big triangle, 1.5. Okay. All right. Good on that page, friends? All right, so let's try some more. Anybody need more time there? Example 3, find a corresponding length. Okay. In the diagram, UVW is similar to QRS. Find the length of the median. Oh my gosh. Well, the median is that little mark. The median from S to what here, kids? Okay, I don't know S to T, so I'm going to go in here and be like, I don't know this distance, so I should probably call it a what? Should we call it X? Okay, what does X correspond to, kids? I would say X is to 12. Okay, so since I went from the big triangle to the small triangle, I would say X is to 12 as, let's pick on this 36. What's 36 correspond to down here? I would say X is to 12 as, what is to what here, kids? Okay, let me pull my calculator. This is pretty easy, isn't it? Guys, tell me what to punch in. 36 times 12 divided by what? What do we get? So the median from S to T is what distance? Yep. Can you set up a proportion? If I say blank is to blank as another side is to another side, can you figure that out? Feeling pretty good about this so far? Okay, let's keep rolling. Any questions up to this point, my friends? All right. This theorem I don't much care for right here. Okay, perimeters of a similar polygon. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side length. Here's what this is saying, okay? I'm going to end with example 4 today, but I'm just going to do this. I'm going to call this distance, I don't know how I want to do this. Let's call this a 4, 5, 6, and 7. Okay, you guys good there? Okay, and on the bigger one right here, let's call this, I don't know, how about an 8? If these are similar, what's the distance from P to Q have to be? What's the distance from K to N, kids? I put a 4 in there, right? What did I put in for PS? 8. So what am I doing to all the distances in green to get the distances over there on the red one? Multiply by 2. So PQ would have to be what? Q to R would have to be and S to R would have to be what? Okay, all this formula is saying is this, kids. Okay, if I compared 4 over 8, what ratio does that become? What is 4 divided by 8? What's 5 divided by 10? And other way around, we're going 4 over 8. So it wouldn't be 2, but it would be 1. Okay, 5 over 10 would be 1/2, wouldn't it? Wouldn't 6 over 12 be a half? Okay, well, what would 7 over 14 be? That would be 1/2 also, wouldn't it? What they're saying is this: if you add the whole perimeter up, if you add all the sides over here, that ratio of the perimeter would have to be the same. Well, I should say it this way: the ratio of this small perimeter to the large perimeter would have to be the same as this ratio that we're getting 1/2 on each side. So let's just prove that real quickly. Kids, what's the perimeter? 4, 5, 6, and 7 add up to? Don't you get a total perimeter of 22 when you add those up? 4 plus 5 plus 6 plus 7. You guys add 8, 10, 12, and 14 for me. What do you get there? 44? Kids, if I added all the sides up for these similar figures, in other words, the perimeter of the small figure, the perimeter of the large figure, what's 22 over 44 going to reduce to? It's going to be 1/2 again, isn't it? Okay. So guys, all this is saying is this: if you know the perimeter, I should say this, if you know the ratio of one side to the other, then you know the perimeter should be half of it. Because guys, aren't corresponding sides of the smaller one going to be half of all sides in the bigger one? So does it make sense that it would be half the distance? Okay, so that's what that's talking about. So let's finish up example 4 and call it day today. Anybody want to read number 4 for me? I got it. Your neighbor has decided to enlarge his garden. Okay, the garden is rectangular with a width of 6 feet and a length of 15 feet. The new garden will be similar to the original one, and I think that that's the part that we need to highlight right here. The new garden will be what? Similar to the original one, but it's going to have a length of 35 feet. Find the perimeter of the original garden and the enlarged garden. Well, let's start with a couple rectangles. You guys okay with that? Because it said the gardens were rectangular, right? Okay, and then I'll draw another rectangular garden. But the next one's going to be bigger, right? You guys with me on that? Excuse me. I don't want to do that. I don't know why it's doing that. All right. I'm going to erase this one. I don't like that one. I don't like this one either. You know what I'm going to do? Let's see if I can cheat this a little bit. Oh, where are my shapes? Here we go. Yeah. Don't want that. Why is this doing this? I'm not sure what's happening here. Just draw 2 rectangles, one smaller than the other, okay? Make them look kind of good. Doesn't have to be perfect. First thing we know, these 2 rectangles are going to be, what did I highlight over there in the problem, kids? Okay, it says the original garden is 6 feet wide and how many feet long? Okay, which would make this right side how long, kids? It would make this what? Okay, now, it says they have to be similar, so same shape, but different sizes, okay? It said in the bigger garden, we're going to have a new length of how many feet? 35. Did they tell you what the width is going to be at all, kids? Okay, so we don't know what this width is right here. We wanted to find a perimeter of the original garden and the enlarged one. Okay. Well, any way to find x right there, kids? What can I set up here? Tell me what to set up to solve for x. I would say x is to what? 6 as, okay, do we know two other lengths in both the larger and the smaller figure that correspond to each other? I can say x is to 6 as 35 is to, okay, would 35 go up top or the bottom the way I've set this up? Have to be the top because x was the top, right? I went from big compared to small, big compared to small. You with me on that? So I'm going to take 35 times what here, kids? Divide by what? What do we get for a value there for x? X is 14. Okay. Top up here would be 35. Right side would be what? Okay, so wouldn't my perimeter have to be? Wouldn't it be 14 plus 35 plus 35 for the big one? Agreed there? And that would be equal to 98. Guys, what's the perimeter of the small one going to be? I should write big perimeter here. And how'd you get that? Yep. 15 plus 15 plus, and you said that was how much? Yep. Kids, when you get a chance, see if you've got big ideas 8.2 done. Practice puzzle 8.2 if you're done. Double check Dave's for me on some things. You guys good with that? Any questions for me? All right.
Reminder that juniors, you head straight to the for advisory. Juniors, go straight to the auditorium for advisory.
Happy birthday.
Thank you. Thank you. Getting old. All right, guys. I need to get attendance here quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. Briar's here, right? He's 10. And Jaden's 11. She just went to the bathroom too. Kids, do you have your Chromebooks today? No? Yes? I've got to see what we're even doing. So give me a second. Let me get attendance here. Okay. Let's see. We're advisory today, right? How was break, everybody? Yeah? Seemed short, didn't it? That storm that's down in Missouri. Man, I was so hoping it would track north. You guys hear about all that snow down there?
Yeah.
They're getting like 2 feet of snow right now.
My boyfriend's grandparents said that they had 12 inches as of last night.
Yeah. Now, didn't Brooklyn move down that way?
Yeah, she moved to Kansas, and like I saw like a TikTok, and she was posted, and like there was like
Big storm down that way.
and it was like
There was a
Do you have her number? Do you ever message her and see if she's at? Just ask her if she had school today.
oh yeah, I will. 'Cause I have her on TikTok.
Yeah.
There was a pile of 30 vehicles on
Really?
the interstate. The sheriffs were posting like, why are we still even letting these people on the interstate?
Yeah, it's pretty bad down that way. All right, let me get advisory here. How about, let's see. So I've got Hunter's here, Kate's here, Deshawn's here, Kaylee's here, Bristol's here. Cameron here today? No? Okay. What about, let's see, Briar's here, Aubrey's here, Ray is here, Ruby is here, Jaden is here. How about Amber? Amber here? Okay. So just those two right now? Okay. All right, my friends. Well, why is my... Why can't I... That's weird. I don't know why it won't let me... Oh, that's weird. I don't even have a... Oh, whatever. Okay, guys, let me pull up what I need to do with you guys here today. I don't think this is going to take very long. All right, grade 12 today. Understanding resources in college. I'm going to read some things to you today. Says the number one thing you can do for yourself as a college student is get to know the campus resources available to you. This doesn't matter if you're attending community college, university, or tech school for a certificate program. Before we jump to the resources on campus, let's explore things you may experience as you transition and or while you're completing completing your future plans. What are some things you could experience next year? So examples that they talk about is this. I don't know what your guys' plan is after high school, but some things that are tough for kids. What's the first one say there, kids? Academic struggles, uh, trouble finding a peer group. Anybody like me is just a homebody and wants to be at home all the time? Yeah. Okay, I'm like that. What about medical concerns? There'll be some medical concerns. Guys, you get to school, the campuses have a place for you to go for medical stuff. Okay. If you're like me, number 5 was a big one. Financial concerns. How am I going to pay for all this? And even number 6. What's that?
Are you still paying on yours?
No, thank goodness. I was pretty fortunate. My parents took care of a lot of it for me. So, yeah, but I also spent a lot of time working while I was in college too. So, um, this is a kind of a big. I don't know. Is there some people that haven't decided on what goals they have yet? And it's okay if you haven't. I haven't. I don't know. And then number 7. Anybody stressed to go on to the next level after high school? A little bit. Okay. So, guys, it says colleges know you'll experience some or most of these while you're in attendance, and it's not necessarily just in your first year. It can happen through your junior, senior year, but whatever. Throughout your time while you're earning your degree or certification, college resources are there because they want to support you and because they work, okay? Mrs. Chris has got a short activity she wants you to do. Says, I'm going to break you into groups. There's 6 resources. Decide how many groups will work best. I don't know. We can just kind of do this together as a group. And each group gets at least one campus resource. Read about these. So, I don't know. Who wants the financial aid office? I think we can. Should we just go through these as a group?
Yeah.
Okay. What do you think financial aid office is for?
Financial aid.
Help you with finances. Okay. I'm just going to kind this right here. Okay, what do you think a counseling center's for? Yep, I need to find, is there a... Okay. I thought there would be... I want to read this one more time. I'm going to break you into groups, and each group gets at least one campus resource. Read about what each resource does. Oh, it's on the back here. Can I read the financial aid one to you? It says the financial aid office is a student's source for information and resources regarding paying for college and planning for physical future. Did you guys have to fill something out like a FAFSA thing or something like that? Have you guys done that already? Okay, so make sure that your parents get that done. They can provide you assistance on financial literacy, eligibility, scholarship assistance, and more. Guys, I'm going to tell you right now, there's a lot of scholarships out there. Have you guys been applying for some of those? And it's serious. Some of them are just a simple apply. Companies will do it. Like, there's one that's like out there, the Eastern Iowa REC one, basically. It's like a power company. If you live in the power companies, how many of you guys live in the country? Anybody? Okay. REC is like your provider. Pretty good chance that you just go to them, apply online, they're going to give you $1,000 simply for being in school and having good things. So I don't know. Somebody right now I want to get on top of that. So financial aid, we're good there. Counseling center, what do you guys think that's for? Yeah, counseling center provides students confidential therapy services both in person and through teletherapy. Students usually call and make an appointment with their student ID and referred to by a student health clinic. Sessions are usually free since you're a student and the insurance is used. Crisis services are usually available. Guys, what do you think the wellness center is? The wellness center, we had a buzzsaw of an intramural basketball team. We were so good. I was at the rec center all the time playing basketball. In fact, a couple of people that when I went to college, a couple of people that were on my team came from this school. Okay? The use of wellness or recreation center is usually included in your student fees. All students get a membership, basic access to fitness equipment, intramurals. We were so good at intramural basketball. Some special events, fitness classes, me when I was playing basketball in the intramurals. I was pretty good at it. The Slim Reaper. Some activities may not cost much more. Okay. Guys, what do you think the Academic Learning Center is? The Academic Learning Center is usually available to assist students in developing the academic skills necessary to be successful in college. Yeah, I think of this as kind of like tutoring. If you need extra help, find some people to tutor you a little bit. This can include study skills, drafting, essays, expanding math skills, preparing for tests, revising papers, developing lab reports, and more. These are usually free. Guys, what's an academic advising career center? Basically, this is kind of like saying, if this is the path you want to choose, then these are the classes you should probably take. I'm not going to read this one, okay? What's a student health clinic?
Where you go to, they look at you and make
Yep.
sure.
Yep. So if you get sick, you got a place to go on campus, okay? There's people that work there, okay? Kids, I think you know all this already. Is that true?
Yeah.
Yeah. How many of you guys have made some college visits yet? Anybody? Yeah? How many have been on a college visit yet? Yeah? Okay. How many know where you're going after high school? Okay. Everybody's still kind of up in the air about what they want to do after high school? I think the thing that gets me discouraged sometimes, not everybody's good with college, and that's fine. People that go to work right away, that's a good thing for you, okay? If you can get some kind of internship and something that you like to, I think that's a good route to go. All right, I think trades are becoming something that's more and more important as we go through this. So, anybody have any questions on any of these right here? Guys, I'm just going to read these last things to think about, okay? You're paying for education. If you're struggling in a class and more than one, confused about a major or having troubles finding a major and or career, don't hesitate to ask for help. Don't ever hesitate to ask for help, okay? I have a lot of kids that ask for help about math problems when they get to college. So I'm always available to help with those. Plus, I like to see those. So if you ever get into a math class and you're not sure about, reach out, okay? Everyone needs to think about their mental health. I think that we all know that. There's the freshman 15 thing. What's this freshman 15 thing? It's the biggest reason students behind gaining weight. It's calling about gaining weight. Okay? Gaining weight in your freshman year, because most colleges, when you go eat, you can eat as much as you want. Make sure to take care of your physical and mental health by getting to the wellness center. Okay? And then it says find a balance. Your post-secondary journey is your last step before entering the real world. Keep in mind that in college you have that power. Your parents don't call professors or call you in sick. Ruby, when you get to school, I'm going to call your professors every day. Find out what the heck is going on. Sound good? I'm going to call your professors every single day. All right? Just to check in on you. Is that okay? Yeah, okay. That doesn't mean you made it to school. At least right here, I can see you here. Ruby, how many times do I check in on your grades? Okay. All right. But we know why, 0, right? Okay. All right. Guys, I think you know all this right here. You have any questions? Thanks for being a good group. You guys can do what you want the last 13 minutes, okay? Oh, by the way, guys, today's a black day. Did you know that? I don't know if that matters to anybody, but today is a black day for you, okay? Oh. FAFSA.
Did I tell you I got absolutely nothing from that?
0?
0.
I knew that would happen. I tell you, the Vikings got destroyed last night.
Dude, that was so bad. They could not do anything.
That was bad.
Listen, I know the Lions are good, but Minnesota's not that bad.
Yeah. If they would have scored on those 3 end zone, it would have been actually a close game. What, 27-31?
They played tight the whole time. They looked like they were scared to death.
But it was awful.
I saw both
I went
after the second half.
I stayed up the whole game. I was like, well, I either win with my team or I lose with my team. But I'm watching them all the way through.
I woke up at like, I don't know, 9 o'clock to like my dad just screaming.
I could not fall asleep last night.
I woke up at 4 and I
No, it was like 11:30. I was like,
Yeah.
it's really
at 4 a.m. I couldn't sleep, and I really could not go back to sleep. I was like, I can't take a
Take Benadryl or something.
That's what I've been taking is allergy.
Bradley's pepperoni fridge. Mom wants to get groceries.
Yeah, she might.
Our chemistry quiz.
Really not yet.
Well, you're thinking about physics.
There's really a local scholarship. I know Allison did like 3 scholarships over break.
And I signed into that Scottish universe thing. I didn't do anything on that. I just got into it. I have until February 1st, so I gotta keep going. But I think all you have to do is literally just apply for them. And then write a short essay.
Yeah, all of mine are like essays.
It's like 1,000 words or something like that.
Oh, yeah.
Maybe I started the Farm Bureau one.
First I got it, but now I
For members, and then I sent them like I haven't worked on it for like 3 weeks, and I write. There's all probably enough here that I can keep it.
Yeah, they're all like specific. I was like,
Great, and this one is But then again, what's so great if you do it? I'm gonna keep this.
What's that, buddy?
He gave us his book, so I'm gonna keep it.
Okay. Let me look what I got.
do you have any chocolate?
Oh yeah.
Yeah, why can't I would just like use Canvas like everyone else.
think Mom got my Daytona 500 tickets? Because when the Vikings play like they did last night, and they'll probably lose in the first round of the playoffs, then Daytona becomes important.
Hey, don't you guys play the Rams?
Huh?
Did we play the Rams first round?
I think the Rams are going to beat them.
Packers played the Eagles.
That ain't going to be good.
They're not going to beat the Eagles. Eagles are going to stop.
Well, is Hurts playing or not?
Huh?
Is Hurts playing on Sunday? If Hurts doesn't play, Green Bay's got a chance. How do you get beat by the Bears at home?
Jordan Love got hurt.
Who?
Our quarterback got hurt.
Is he going to play? What's his injury? That's not good.
Can I go talk to Chris quick?
Mm-hmm.
Hopefully she's in. Actually, no, she's probably in the on.
Mm-hmm.
I have apparently a $900 bill at Hawkeye.
For what?
Glasses.
No, you don't.
What?
No, you don't.
That's what I thought. But
Have Briar Pat.
hopefully. Dude, it like I look so confused. Did you know those two girls they were yapping about Dawn and Natalie? Oh yes. I was like, did you see her? It was black. I wish I saw it. So is it what? Is it one assignment a week for her? Is that all it is? Well, it's really different than the other schools. Well, no, because it's also like there's a quiz. On the syllabus,